Hello guys, I am Paul McWhorter from TopTechBoy.com, and what I will be doing today is I will be giving you your first introduction to the Arduino microcontroller. I think programming a microcontroller is something that's intimidating to a lot of people, but I will promise you by the end of this first tutorial you will have written your first program, you will have downloaded it into the Arduino, and it will have done something interesting. I think that the Arduino is simple enough that a 7th or 8th grader could do it. If you're a little smarter, a little more advanced technologically, maybe a 3rd or 4th grader could do it. So I'm going to take you through it step by step. This first lesson we're going to make a light blink, and then we're going to go all the way to showing you how to build an instrument package based on the Arduino that you can send into space. This is a picture that was taken by an Arduino based system that we developed and sent to 120,000 feet. So we're going to start by blinking an LED, and we're going to go all the way to being able to build a space probe. Not all in lesson one. Lesson one will be blinking the LED. But what I want to do is I want you to know is I'm going to take you through this step by step. I'm not going to assume that you have a degree in computer science. I'm going to take you through it step by step. It's not going to be anything harder than, installing a printer or something like that. So first of all, we need a microcontroller. The microcontroller we're going to be working with is the Arduino. The reason I chose the Arduino is there is such an incredible amount of infrastructure out there. Almost anything that you want to do with the Arduino, someone else has already done. There's incredible resources, incredible infrastructure, and you can get the Arduino for about 20 bucks. And so it's a very affordable platform to work on. I've got some resources listed on my website, toptechboy.com. If you visit there, I can help get you hooked up with one, or you can find one in any number of different places. The thing about this is you can get the bare Arduino for about 25 bucks. I'll show you down here one that's set up and ready to go. But what I'm really going to suggest is if you're going to go through this, I would suggest that you go ahead and buy the SparkFun Inventor Kit. The thing about the SparkFun Inventor Kit, it has all the wires and connectors. It has all types of components to take you through about 10 or 15 different projects. The Arduino Inventor, the SparkFun Inventor Kit comes with a number of different sensors, a number of different actuators, and a lot of these subsequent lessons are going to be based on components in the SparkFun Inventor Kit. The SparkFun Inventor Kit is about 100 bucks. To me, it represents a really great value. You could probably go out and try to buy all the different parts yourself, just starting with the bare Arduino, but I think in the end that you're probably going to be better off if you go ahead and get the SparkFun Inventor Kit. SparkFun is a great company, had great luck with them, and highly recommend their products. Okay, but today we're just starting with the bare Arduino, and we're going to see how you would go about working with it. First thing is you got to just take a couple of minutes to install some software. Really, this is no harder than if you did something like install a printer. The best place to go to do this is you can go to this website, which is called the Arduino website, and it is at arduino.cc/en/guide/windows. Okay, if you go there, it has a quick overview of how to download the software. The first thing you do is you download the Arduino environment. That is your integrated development environment. That's the palette on which you will create your platforms. You just click on the download page, and I'm on Windows, so I downloaded the Windows software. Then you click on it, and it installs it. Very, very simple. And then basically what you got to do is plug the board in. There's a USB cable over here. You just plug it in with a standard USB cable. Nothing difficult there. And the final thing is you have to show the Arduino where the drivers are. You can go through this, but it's basically very simple. You go to the device manager, you right mouse click on that serial port, and then you point to where the software is for the drivers. This takes you through it in a little bit more detail. I think that you could probably do this in about 5 or 10 minutes, so I'm not going to bore you by taking you through step by step with that. But once that is installed, then what you do is you launch your Arduino environment, and it comes up looking like this. The first thing that you're going to see is every Arduino program has two parts. It has a void setup, where you set the Arduino up, and then it has a void loop. The things that you want to do one time, like setting up your pins, you will do in your void setup. And the things that you want to do over and over and over, you do in your void loop. And so basically 2 parts of the program, the void setup and the void loop. But before you actually get going, there's 2 things that you need to set in your environment. The first thing is you have to tell your integrated development environment which Arduino board that you have. Chances are you have the Arduino Uno. Okay, I have the Uno Rev 3. Almost all Arduinos out there are the Arduino Uno. You tell it that that's what you have by going to Tools and Board, and you can see here that mine is already set on Arduino Uno. But you want to go ahead and do that, do that, because if for some reason that is not set right, you will have problems. The second thing you have to do is you have to tell the environment which serial port your board is connected to. And to do that, you come down to Tools, Port, and you can see that mine's on COM11. You want to go ahead and check though, because sometimes you have more than one option here and you've got to tell it which one it's on. And if you see like it pop up COM4 and COM7, how do you know whether your board is on COM4 or COM7? And I'll show you. You come over here and you get the Arduino, okay? You see mine's already on the serial port, and you unplug it. When you unplug it, you hear that all of a sudden the USB is not happy because you heard that ding dong because you've unplugged something from the USB that it doesn't like. If I come back, now you see that that COM11, that port 11 is no longer there. It has disappeared. Because COM11 disappeared, that tells me that in fact my Arduino was on COM11. So let's come back, put this back, and now we are going to be pretty sure, get that nice and neat there. We're going to be pretty sure when we come back to port COM11 is back. So that tells us, yes, in fact, our Arduino is on COM port 11. Now the reason I go through all that is a lot of times when you plug it in, there's more than one choice, and that's how you can absolutely positively make sure that you've got it set on the right choice. Okay, now let's see if we can make this do something. And so basically if we if we look down here at the Arduino, we can see that there's all types of different pins. On this side, there are basically 13 different pins starting at pin 0 all the way up to pin 13. After pin 13, there's a ground, and so if you want to use an external circuit, if you want to do something, you can connect to the Arduino ground through that one. But right now, we're going to be talking about pins 0 through 13. If you have an external breadboard, which we'll talk about in the next Arduino tutorial, you can bring those pins out and you can start turning LEDs on and off. But today, we want to make it where you write your first program, and we want it to be as simple as possible. And so to make it as simple as possible, there's a little thing here, and that is, let me see if I can focus this a little better. There's a little thing here, and that is that on pin 13, there is an LED on the board already hooked up. This little LED is hooked up to pin 13. And so if we do something to pin 13, that connects to that LED. And so let's see if we can turn that LED on as our first program. Okay, our very first program. Well, if you're going to talk to pin 13, you have to tell the Arduino what pin 13 is, and you do that as a pin mode. You set your pin modes. Of all pins you're going to use, you have to set your pin modes. You set them one time, so you do it inside the void setup. One of the things about this programming language is that the clauses begin with an open curly bracket and they end with a closed curly bracket. So we say void setup. Okay, that's going to be kind of like my clause. That's going to be kind of like my paragraph. It begins with the open curly bracket and it ends with the closed curly bracket. Everything you do in Arduino, anytime you have any type of clause, it will begin with the open curly bracket and it will end with the closed curly bracket. Everything that you do between those two curly brackets will be that clause of the setup. Well, what do we want to do? We want to do our pin modes. How many pins are we working with? This time only one. We're only working with one because we're only working with pin 13. So we have to set our pin modes. So we have to go pin mode. You have to do it exactly like I'm showing you here. Notice that it's PIM and then capital MODE. That's actually called bumpy text, and it's used a lot in programming. And that is, you don't want to put spaces between words, but the way you sort of show one word from another is you make capital the first letter of the next word. So you can see this is the word pin mode, and it has to be capitalized like that. That is case sensitive. Now you open up your parentheses and you put your arguments inside of these parentheses, and the arguments that you want is you're going to set a pin mode. You have to tell it which pin are you setting up. I'm setting up 13, and it can be either an input or an output. If you're going to be reading from pin 13, it's an input. If you're going to be writing to pin 13, sending an output to it, it's an output. We are writing to it, so we're going to say that it's an output. Also notice that output is case sensitive. It is all capital. Notice to pay attention to the colors, that because pin mode turned orange because the Arduino recognized that that was a command. It's like, hey, I recognize pin mode. I know what you're talking about. So when I see this pin mode turn orange, it kind of gives me a warm, fuzzy feeling that the Arduino environment recognizes what I just said. Also, when I typed in output, it kind of turned blue. That's telling me that Arduino recognized that word. And so what we have here is we have now told the Arduino that pin number 13 is going to be an output. We're going to be sending information to it. So now that we've done that, we can come down here in our void loop and we can do our first command. And what we are going to do is we are going to do a digital write. And so what we're going to do is we're going to turn pin 13 on, or send pin 13 high. Or basically what you're doing is you're sending a 7-volt signal to pin 13. When I send I'm sending a 5-volt signal to pin 13. When I send a 5-volt signal to pin 13, that should turn this little LED on. So what we're going to do is we're going to do a digital write. We got to tell it, which pin are we writing to? We are writing to pin 13. And what are we doing? Are we sending it high or are we sending it low? We are sending it high. Okay. And then all lines just about in the Arduino end with a semicolon. So when I did my pin mode, I ended with a semicolon. When I do my digital write, pin 13 high, we end in a semicolon. Now, just because I write it on this screen does not mean that it automatically goes down into the Arduino. To get it into the Arduino, it's got to be compiled, and then the code has to be downloaded. And we can do that with the click of one button. This is this button. What this button does is it compiles the code and it sends it on down to the Arduino. So if I click this and I've done everything right, I usually hold my breath because I make lots of mistakes. You see that it's compiling. Everything's green. That means it's happy, and it has gone down in there, and look what happened. We sent that pin 13 high, and that turned that LED on. If we brought a wire off of this pin 13 and externally hooked it to an LED, that would turn the LED on. Well, that's kind of exciting. If I can turn this LED on that's on board, I could bring a wire out and I could jumper it over to something else, and I could turn an external LED on. And the cool thing is that if I can turn an LED on, I could turn a motor on. And if I could turn a motor on, I could open a door or open a window. And so even though this is a very, very simple command, it's very, very powerful because now programmatically, I just sent a voltage to a pin. I turned an LED on. It could be a motor, or it could be a servo, or it could be any number of different things. But we've written our first program and we've downloaded it. So I hope you followed along with me, and I hope that you've been able to write your first program. Now I'm going to do one more thing in this video because I think that it's we've made some good progress, and I just want to show you one more little thing, and that is that really it's a good programming practice not to come down here in the program and say make pin 13 an output and then write pin 13 high. Let's play around with this a little more before I introduce that. Let me just go ahead and say, do you think that we could turn that LED off? What do you think I would want to set this to if I wanted to turn the LED off? I turned it to high and it went on. What would you do if you wanted to turn it off? Well, how about we make it low? That's probably what you would have guessed. But wait a minute. The LED didn't go off. Why did the LED not go off? Because I have not sent this code down into the Arduino yet. Remember, we got to compile it and send it down there. So I click this. It's compiling. It's sending it down, and it turned that off. Okay, it turned it off. Let's see if we can turn it back on. We're going to go high again. Make it high. and you have to spell it right. Okay, and watch this over here if we're watching. Okay, the LED comes back on. So you see we can turn it on, we can turn it off from our program. Now, one of the things I want to introduce here in this first lesson is it's really very poor programming practice to come in and say make the pin mode of 13 an output and then digital write 13, because as your program gets more and more and more complicated, you get more and more stuff hooked up, it's harder to keep track of. So what you want to do is you want to set variables. And so we're going to set a global variable, which means we're going to do it up here at the top before we do anything else. And what we're going to do is we're going to declare a variable. And the type of variable that you can have is an int, which would be an integer, a float, which would be like a real number, or a string, which would be like words, like groups of characters. Well, you always remember having to learn in math class about integers and reals, and this is where you're actually going to use it. And so you think, if we're going to use a variable that's going to declare a pin, and the numbers could be 0, 1, 2, 3, up through 13, because our pins go 0 to 13, what type of variable would you need? You wouldn't need it to be a real number. You wouldn't need it to be a floating point number or a float. You would just need it to be an integer, because pins are always pin 1, pin 2, pin 3, or up to pin 13. You would never have a pin 2.5. So what we need to do is we need to declare our variable, and we're going to say our variable is an int, int. And look at that, it turns orange. It recognizes that word and says, hey man, I know what an int is. So that's good. It recognizes what we're trying to do. And now we got to give that variable a name. Okay, you can name it anything you want. You can name it anything that you want. I'm going to name mine LED pin. Okay, you could have called it a gazebo if you wanted, but what's important is you want to name your variables so that when you come back and look at your code later, it sort of makes sense what you were trying to do. So LED pin, that tells me that I'm going to set a pin to something. And now I can go ahead and tell it which it is. What number do I want to put in LED pin? We're working with pin 13. So now I have a variable. A variable is like a bucket. The bucket is labeled LED pin. Now I put a value in that bucket. The value that I put in that bucket is 13. So down here now, I don't have to type in 13. I can put the variable name, and I put in LED pin. And I come down here, instead of saying 13, I say LED. Okay. And the good thing about this is now if I ever want to change it, I just change it in one place and it changes throughout the program. And if you go in and keep putting 13, 13, 13, 13, 13 down here 50 different times in your program every time you use it, then if you want to go to pin 12 for some reason, you want to change to pin 12, you've got to change it everywhere, and I guarantee you're going to miss one and you're going to have a problem that takes you a few days to figure out where it is. So therefore we declare variables. We declare our variables up at the top, and then we use variables instead of using constants in the program. So here we've declared the variable LED pin. It's an integer, and we put a value of 13 into it. Then anywhere that we want to use this number, we use the variable. So pin mode is now LED pin, and digital write is now LED pin. What's LED pin? It's an integer with a variable with a value 13 that we set up here. So let's click on this, and you can see that it's still happy. It downloads, and then the light comes on. So everything is working. Well, we've seen that we can turn the light on, we can turn the light off. What if we try to blink the light? Well, to blink the light, we would want to turn it on, digital write LED pin high, and then we would want to do another command, digital write LED pin again, and this time set it what? Low. Okay, so this will turn that pin off. So now it's going to go on, it's going to go off, and we should see it blink. So let's download the code, and then let's look over here. It downloads, and wait a minute, it doesn't look like it's blinking. It sort of isn't. It's kind of like the brightness went down. It's kind of on constantly, but it is just very dim. So what happened there? Well, what happened is that the Arduino can execute thousands and thousands of lines of code a second, and so that's turning that LED on and off so quickly that your eye can't even perceive it. What your eye perceives is a dim LED, like it's on half the time and it's off half the time, and so it's going so fast that you can't even see it. So let's come in and let's put a delay in here to slow it down. Let's say we want to do a delay. That's another command that we can do. And the delay parameter, or the argument that goes on delay, is in milliseconds. So there are 1,000 milliseconds in a second. So if we want it to stay on for a second, that would be how many milliseconds? That would be 1,000 milliseconds. Okay. And then if we come over here, we can say we want it to be off for 1,000 milliseconds. So let's look at our code. We tell it, turn the LED on, wait a second, turn the LED off, wait a second. And then because this is in a loop, it's going to keep going back and forth over and over and over. This void loop is going to execute over and over and over. So we say digital write LED pin high, that turns it on. Delay 1,000 milliseconds, that's 1 millisecond. So turn it on, wait a second, turn it off, wait a second, and let's see what happens here. Okay, now if we look, you can see it's on, off, on, off, on, off. It's blinking exactly the way that we told it to. Okay, now what did I do that was not real good here? Again, I started using constants. I shouldn't use a constant down there. Okay, because now if I want to change it, I've got to change it everywhere. Let's create a new variable. This can be an integer too, and why don't we call this wait time, and why don't we set it to 1,000? Okay, now when we come down here, instead of putting a number in, put our variable in. Wait time. Okay, and then we come here. Wait time. Ooh, got to do it exactly right. It's case sensitive. Wait time. Again, I could have called this variable anything I wanted. That's just the label that I'm putting on the bucket. A variable is like a bucket, and the label that I put on it is the name of the variable. The label I put on this variable is wait time. The value that I put in the bucket is 1,000. So if I come down here, look at that. Now if I run it, let's look, everybody's happy, it's staying green, and everybody's happy. And now if I look down here, it's on for a second, off, on, off, on, off, on, off, just like I told it to do up here. But now the cool thing is that if I want to change the amount of time it's on, let's say we want it on for a quarter second, off for a quarter second, that'd be, what's a fourth of 1,000 milliseconds? That would be 250. So if I change that to 250, this should blink faster. Okay, let's download it and look at that. On, off, on, off, on, off. You see how it's going a lot faster now? On, off, on, off, on, off, on, off. Well, what if I want it to just blink and then stay off for a long time, and blink and stay off for a long time? Well, there I would want like two variables. I would want a wait time on, and I would want a second variable, integer, wait time off. And then this would be, let's say that we want it on for just 1/10 of a second, so let's go 100 milliseconds, and then we want it off for 900 milliseconds. And so what this is going to be, it's going to be on for 1/10 of a second, off for 9/10 of a second. And then it's inside this void loop, so it's going to keep looping. So let's come down here and look at this. Ooh, oh, remember, I've got to change it down here, so this would be on. Delay wait time on, and then here it would be delay wait time off. Somebody should have warned me about that when I made that mistake, okay? So let's look here. Downloading it, it's happy. And then look, you see it's on for 1/10, and then it's off most of the time. It's on for 1/10 and it's off for most of the time. What if we wanted it on most of the time and off the other way? Okay, we could come up here, we could make this 900, and then we can make this 100. Okay, and then let's download this. Okay, as you see, it's on most of the time and it's off, on most of the time and it's off. Okay, so this is showing you what we learned in this first lesson. You've written your first program, you've learned how to declare variables, you learned that it's a lot better to use variables than it is to just plug numbers down in here, because then we can just do our changes up here and it makes it work a lot better. And you've written your first program and you've made this light do things. What I want you to do is I want you to play with this, that you could come in and do more than just these rights. You could turn it on and off fast and then on and off slow. Just sit and do some creative things where you make this light do what you want it to do. And that's your assignment for tomorrow. Then the next thing that we're going to do in the next lesson is, in lesson number 2, we're going to go in and start actually building a circuit separately, where that circuit is going to be controlled by this. What I will promise you is, if you will stick with these lessons, I will take you through things step by step by step. You've written your first program. In tomorrow's lesson, lesson number 2, you will build your first circuit that will be controlled by this, and little by little we'll build until you get all the way to the point that you can start building your own instrumentation to send to space. Okay, I will take you through. We will start by blinking an LED, which we will do today, which we did today, and you will go all the way to be able to go to space like we did here and send pictures back. So again, my name is Paul McWhorter. I am from toptechboy.com, and hope you will subscribe to this channel and continue to tune into these lessons. Take it easy, guys.